Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to talk about how to utilize the formulas we derived in our last lesson to figure out different areas, perimeters, etc. So again, just today is an application day. We've already come up with the formulas. I'd have them next to you so that you can then choose the right ones to apply here. It doesn't mean that you're just going to pick a formula and substitute numbers in. You're going to see that, you're going to have to still do some conceptual thinking here to figure out, how to utilize several different formulas within one problem to figure out the area, perimeter, etc. So we are going to start off with two fairly easy ones. These are just single figures. So go ahead, pause the video, figure out the area of number 1 and number 2. Okay, so the first one, circle. We know that the area of a circle is pi r squared. Here we just have to be careful. The radius here is 6, not 12. 12 is the diameter. So area is equal to pi times 6 squared. It does say to round to the nearest square inch. So that is going to be the area is approximately equal to 113 inches squared, or square inches. We have a trapezoid over here. If you forget the area of a trapezoid, remember you could split the trapezoid into a couple of triangles and figure out that way. But if we want to use the area formula for a trapezoid, 1/2 times base 1 plus base 2 times h. Base 1, doesn't matter which one you go with. One of them is 20, the other one is 25. The height here is 15, right? Height is the perpendicular distance between the bases, not the slanted height. So this area becomes 1/2 times 45 times 15. And this gives us 300, just say rounded nearest square centimeter. So area is approximately equal to 338 square centimeters, or centimeters squared. Okay, again, just a little intro here. The ones that we're moving on to next are what we call composite figures. These are figures that can be broken down into simple shapes like triangles, rectangles, circles, and trapezoids. But they don't necessarily have a specific name themselves. Some of them might. They may be some sort of irregular polygon, but some of them might not be polygons. They may have some curved edges somewhere while the other edges are straight. So again, the easiest way to figure these out is to break them down. Oops. Break them down into shapes that we know how to find the area of. Now we're actually going to skip this one, and we're going to go to the first one on the next page. We're going to find the area of this entire figure, and we are going to round to the nearest tenth. I'd encourage you to pause the video, see if you can figure out this total area by breaking the composite figure down into more simpler shapes, and then find the area of those and adding them all together. Okay, so it looks like we have 3 different shapes here that we can find the individual areas of. We have this half circle, we have a rectangle, and we have a triangle. The first thing that I'm going to do is I'm going to find the height, or you could call it the base, of this rectangle. It's also the base of the height of the triangle, depending on which figure you're looking for. But I need to find that because that's actually the link. It's a dimension of the triangle I need, it's a dimension of the rectangle I need, and it's going to help us figure out the radius of the circle as well. So, little Pythagorean theorem. I have my hypotenuse, which is 10.2. we're calling that h. So h squared plus something is equal to 10.2 squared. I said something because I'm not actually given this dimension here. However, I know that this entire thing is 7.8. I know that this portion is 3, so this piece has to be 4.8. So h squared plus 4.8 squared is equal to 10.2 squared. This one actually turns out quite nicely. I'm not going to go through all the work on paper, but you end up getting h is equal to 9 exactly if you don't do any rounding in the middle of the problem. So h is equal to 9. That really helps out because now I can figure out just about everything else based off of that. Let's do the area of the triangle first. I'm just going to color coordinate, so in green I'm talking about the area of the triangle. 1/2 times the base, so 1/2 times 9 times 4.8. Area of the rectangle, whoops. I'm just going to put all the formulas up here and we'll simplify in a second. Area of the rectangle is just 9 times 3. Area of the semicircle, or the half circle, is going to be equal to 1/2 pi r squared. So 1/2 pi. My radius is half of 9, so 4.5 squared. Again, area of a full circle is pi r squared, area of a semicircle or half circle, 1/2 pi r squared. The area of the triangle turns out to be 21.6 square feet. Area of the rectangle, 27 square feet. And we are, forget what it says above, round to the nearest, let me just check that real quick so we do it correctly, round to the nearest 10th. So I'm going to go to the nearest 100th because I'm in the middle of my problem. 1/2 times pi times 4.5 squared. That gives us approximately 31.81 square feet. Then, of course, this is a composite figure. So I'm going to add all three of these together. And if I round to the nearest 10th, that gives me approximately 80.4 square feet. Make sure you include those units as well. So again, this sort of composite figure, break it down, add up all the individual areas together. Now we could have a different type of composite figure where we actually have to subtract out some areas. So here we are trying to find the area that is shaded in blue. So just the area that's shaded in blue. Pause the video, see if you can figure that out by breaking the composite figure down. So there were a couple different ways you could do this. You could try to just split the blue area up into two trapezoids and figure it out that way. That does get a bit more tricky with the algebra because there's a dimension that you don't know and you have to let it be represented by x, and then your x's simplify out at the end. So we're not even going to go there. The easiest way is just to find the area of the entire figure and subtract out the area of that white triangle. So I'm going to say area of the whole minus area of the triangle equals area of the blue. So area of the whole, well, that's just a rectangle, right? So I have 18 times 36. Minus the area of the triangle, so minus 1/2 times the base of the triangle, which is 36, times the height of the triangle, which is 9, again, that's going to give me the area of the blue. So if you punch all of this into your calculator, I'm not going to split it up on paper. It's just pretty straightforward. We end up getting 486 square meters is equal to the area of the blue. So again, a different type of composite figure where you may need to subtract out some areas to find the area you're looking for rather than add them all together. Let's look at one more type of problem. And this is when we have a polygon on the coordinate plane. So it says find the area of, in this case it's a quadrilateral. I do give you a hint. It says draw a rectangle that touches each vertex of the quadrilateral, then subtract off the areas of the extra pieces. So I'm actually not going to show you what that looks like. Let's see if you can figure it out on your own. Pause the video and see what you can come up with. Okay, so if I draw a rectangle around this figure, I'm going to get something that looks like this. So now we've just turned it into a problem like we had up above, right? Now we just need to figure out the areas of these shaded regions and subtract them from the whole rectangle to figure out the area of that orange shaded region. So again, just we can just count the units here. We've got, let me do the area of the whole. Area of the whole, that is 8 units. And 7. So I've got 8 times 7, which is equal to 56. That's the area of the whole. Now I have 4 different triangles to figure out the areas of. 1, 2, 3, and 4. So what I'm just going to do, I'm going to do area of number 1. Again, 1/2 base times height. So 1/2. Make sure you go all the way over there. That base is 5. The height is 4. So 1/2, 4 times 5, which is equal to 10. The area of 2, that base is 6. Height is 3. So 1/2 times 6 times 3 gives me 9. Area of 3. And you can see this is not a conceptually difficult process. It just can be tedious because you've got a bunch of stuff to do or to figure out. So I get 1/2 times 2 times 5. That's going to give me 5. And the area of 4, base is 3, height is 2, 1/2, 3. Seems like it's happening more often now. 1/2, 3 times 2, which is equal to 3. So if I subtract all of those green portions off from 56, I get 56 minus all of those, which ends up being 19 plus 8, 27, which gives me 29 units squared. I don't know what my units are, so we just call them units. So 29 units squared would be the area of that shaded figure. So again, just another way of figuring out an area when there's not just a single formula, because there's not a single formula for that shape, or at least we'd have to build the formula from a bunch of other ones. So again, sometimes you need to think outside the box. I guess pun intended here, because we had to draw the box around it. But many different ways to figure out the area of shapes that you may not know a specific formula for. All right, that is going to do it for this lesson. Hopefully we'll see you all back next time, but as always, enjoy the rest of your day.